Hello everyone, my name is Monish son of Raghu and my matrix number is 01DKA22F1145. Today I'm going to explain about the integration. Integration in terms of mathematics is a fundamental concept in calculus that involves determining the area of under a curve or the accumulations of quantities over a given interval. It is the reverse process of differentiations and the primary used to calculate the total change and the integral of the functions. The integrations allow us to find a solution to a wide range of problems such as calculating areas, finding the average value of the functions, determining the total displacement of an object, and analyzing rate of change. Symbolic integrations is denoted by the integral signs and involves the manipulations of functions using specific techniques and formulas. By applying integrations, mathematicians and scientists can model and understand various phenomena across different disciplines. Next, we are going to talk about types of integrations. There are two types of integrations. One of them will be definite integrations. Definite integrations is a technique used to find the exact value of the area under the curve between two specific limits. It is the process of evaluating definite of the functions. For example, if we want to find the area under the curve of the function fx equals to x power of 2 between the limits of x equals to 0 and x equals to 1, we can use definite integrations to find the exact value of this area, which is 1 over 3. Next will be indefinite integrations. Indefinite integrations is the process of finding an antiderivative of a function. It is also known as integrations without limits. The antiderivative of a function is another function whose derivative is equal to the original function. For example, if we want to find the antiderivative of the function which fx equals to x power of 2, we can use indefinite integrations to find the antiderivative of fx is fx equals to 1 over 3 x power of 3 plus c, where c is the constant of integrations. That's all for me. Thank you.
Hello, my name is Diveshwaran Manogram. My matrix number is 01DKA22F1124. Today I'm going to talk about example of application of integration in real life. The daily life example in integration is in sports, which is in basketball. We can use integration to find the arc of the length that formed by the ball.
Hello everyone. In today's video, let's explore the real life applications of integration and see what an integral part of daily life it forms. So let's start. Friends, integration of a function always gives the area under the curve, and this property is used widely in many fields like kinematics. Let's see how. So friends, let's consider the motion of a cycle whose velocity is given by the function v of t equal to square root of 2t. So friends, what would be the distance travelled by this cycle after 1 hour? Well, we know that the area under the velocity time graph will give us the product of velocity and time, which is nothing but the distance that this cycle has travelled. Now, this very area can be easily found by integrating the velocity function from 0 to 1 hour. So, by doing these calculations, friends, we can easily find out that the distance travelled by the cycle after 1 hour is 0.943 kilometers. Friends, you may ask, how do we know that the velocity function is square root of 2t? How do we know whether these equations are linear or non-linear? Well, this is done by collecting data and identifying its nature. We also need to check the constraints of the functions and choose the simplest function possible. Sometimes we can also use existing models. And friends, this is how equations of different scenarios are formed. An important application of integration lies in finding the probability. Let's see how. Friends, integration is very helpful to find the probability of continuous random variable. Now, they are those variables that can take infinite number of possible values, for example, temperature, weight, tire pressure, and many more. So the probability of a continuous random variable x is given by integration a to b of f of x dx. So friends, how does integration come into the picture? Well, that's because the area under the curve of f of x and x from a to b always gives you the probability, which can be very easily calculated using integration. So friends, let's apply this to a pediatric clinic where the probability function of age of babies is given by this equation. Now, if around 40 babies are brought on a particular day, how many can we expect to be under 8 months? So this probability can be easily found by integrating the given function from 0 to 2 by 3. And friends, by doing these calculations, we can arrive at the conclusion that the expected number of babies under 8 months is approximately 10. So probability of continuous random variables without integration is indeed hard to imagine. Let's now see how integration plays a very important role in PID controller. So the PID controller is nothing but a control loop mechanism with feedback. And friends, here is the overall control function where Kp, Ki and Kd are the coefficients for proportional, integral and the derivative terms. Now the PID controller continuously calculates an error value, and this integral unit measures the area between the error values and helps the system to tune into an error of 0. Now friends, this PID controller is extensively used in many fields, including the car cruise control, which is so widely used, and also in the movement and positioning of a robotic arm. Friends, let's now see how integration is so powerful in the world of sounds. Now, the sound power passing through an area can be easily obtained by integrating the sound intensity over an imaginary surface surrounding the source. Now friends, this sound power is very important because it helps predict the sound impact of musical performance venues. We can easily decide if the music is too powerful like this, or if it's too weak for the audience to enjoy, like this. Friends, it's surprising but true that integration helps analyze sports better. Let's see how. Let's consider basketball, in which we need to find the length of the arc that is formed by the ball. So friends, here we need integration because the arc length formula is the definite integral of the velocity function and time. So friends, if the velocity of the ball is 2.24 meters per second at an angle of 45 degrees, then the arc length, say after 2 seconds, can be found by putting these values in the formula to get the arc length to be 17.34 meters. And friends, in this way, integration helps in giving important game-related statistics to improve the team and the player performances. Let's now see how important integration is in econometrics. So friends, here is the Lorenz curve, which graphically represents the inequality in wealth or any other system. It plots the cumulative income against cumulative population. Now we can measure this inequality using a very useful index called the Gini index. It is calculated as the ratio of the area between the perfect equality line and the Lorenz curve to the total area under the equality line. And friends, because we have area under graph, integration definitely comes into play, and the Gini index is given by this integration formula. So by calculating the Gini index of a country, we can determine how the wealth is distributed. So if the area under the graph is 0, it represents perfect equality of income with 0 Gini index. On the other hand, the Gini index of 1 shows extreme inequality in the income. The value of this index hovers between 0 and 1, and the higher the Gini index, the greater the inequality. So, integration is indeed very useful in econometrics. Friends, integration is also very useful to calculate the volumes of different regions. Let's see how with this example of an ocean oil spill. The concentration of the oil is given by this function. Now, if the spill has reached a maximum radius of 5 miles, let's calculate how much oil was spilled. So friends, the region of the oil spill can be found using the disk method of integration to arrive at this formula. And friends, by substituting the different values, we can conclude that the total volume of oil that is spilled is 471.428 barrels. And friends, last but not the least, let's see how integration in Fourier transforms is helping transform the world. So the Fourier transform simply changes a function of time to a function of frequency. And friends, here is the main integration equation that relates the function of time and the function of frequency. Now, Fourier transforms is used extensively in finding solutions of heat flow equations. It is also used in analysis of electrical circuits and also processing different signals. And friends, it's also used in all mobile phones when you are punching in the numbers. As Fourier transform of these input numbers are done for further processing. So, integration in Fourier transforms is invaluable in today's world. So friends, to summarize this video, here are the applications that we have discussed. And friends, these are just some of the numerous applications of integration. So friends, if you found this video useful, do like and share. Please do leave your comments in the comment section below and consider subscribing to enjoy math. So till we meet again in the next video, take care. Bye.
My name is Tirumurugan, son of R. Karnagaran, and my matrix number is 01 DKA 22F1122. So today I will be discussing about the question we have right in front of me here, which has a curve with the equation y, which is x squared plus 2x minus 2, and straight line y, which that is equal to x plus 4. So if we see here, we actually have a curved line and a straight line which is intersecting that curved line with a point A and point B. So we actually have to find the coordinate of the intersection point A and B. So when y is equal to x squared plus 2x minus 1 and y is equal to x plus 4, we actually compare both of those equations into one to create a singular linear equation. When we compare both of those, we actually get x squared plus x minus 6 is equal to 0. And when we factorize that, we actually get x minus 2 in bracket x plus 3 is equal to 0, and the first value of x is equal to 2 and the second value of x is equal to negative 3. So when the value of x is equal to 2, we substitute the value of x into equation number 2 here in order to get the value of y. So when we substitute x is equal to 2, we actually get y is equal to 6. And when x is equal to negative 3, we substitute it back in the second equation and we get that y is equal to negative 3 plus 4 and y is equal to 1. So the coordinate A should be negative 3 and 1, and coordinate B should be negative 2 and 6. So in order to double check, we actually see back into the image. So we actually got the value of coordinate A, that is negative 3 and 1. So if we see here, that is correct indeed, and the value of coordinate B is 2 and 6. So the image seems to be correct, and the answer that we got also seems to be correct. So now we move on to the third and final thing, which is finding the area bounded by a line y is equals to x plus 4 and a curve y which is equals to x squared plus 2x minus 2. So we actually let y1 as x plus 4 and y2 as x squared plus 2x minus 2. And in order to find the area, we actually have to integrate both of those equation as y1 minus y2 dx integrated with the upper limit of 2 and the lower limit of negative 3. And when we substitute both of those, we actually get x plus 4 in bracket minus in bracket x squared plus 2x minus 2 dx integrated with the upper limit of 2 and the lower limit of negative 3. And when we open the brackets, we actually get negative x squared minus x plus 6 dx with the upper limit of 2 and the negative and the lower limit of negative 3. So when we integrate both of those, we actually get negative x cubed over 3 minus x squared over 2 plus 6x with the upper limit of 2 and the lower limit of negative 3. So we actually substitute the value of x with the upper limit and minus it using the lower limit. So we actually get negative 2 cubed over 3 minus 2 square over 2 plus 6 times 2 minus negative 3 cubed over 3 minus negative 2 over 2 plus 6 negative 3 over 2 plus 6 times negative 3. And if we solve that, we actually get negative 8 over 3 minus 2 plus 12 minus 9 plus 9 over 2 plus 18. And if we solve that again, we actually get 125 over 6 units, or in other words, we actually get 20.8333 units square. So that's the whole way of finding the coordinates of intersection point A and B, and finding the area of the both of the lines of the given question. Thank you.
My name is Avinash and my matrix number is 01DKA22F1119. Conclusion. In conclusion, integration is an essential concept in calculus that has many practical applications in science, engineering, and economics. It allows us to find the area under a curve, which is useful in many real-world scenarios. There are two main types of integration: definite and indefinite integration. Definite integration is used to find the exact value of the area under a curve between two specified limits, while indefinite integration is used to find the antiderivative of a function. Integration is a cornerstone of modern mathematics and has many applications in science, engineering, and economics, including physics, chemistry, biology, economics, and finance. Thank you.